Now let's take an gate problem which is asked in year 2004. So I am writing a problem gate ME 2004. In the window air conditioner, in the window air conditioner, the expansion device used is the expansion device used is a capillary tube, B thermostatic expansion valve, thermostatic expansion valve, C automatic expansion valve, and D float valve. So this question is again a straightforward question. We have already discussed during the theory. The expansion device used in vapor compression refrigeration cycle uh, are two types. First is capillary tube and second one is thermostatic valve. So the capillary tube is generally used for a smaller unit and the thermostatic valve is generally used for larger unit. So in our problem there is a window air conditioner. So this one is a small unit. So this kind of unit, capillary tube, will be used as a expansion device. So the correct answer is A, capillary tube. Now let's take in another problem which is asked in year 2004. So I am writing the problem here. Gate ME 2004. Environment friendly refrigerant. Environment friendly refrigerant R134A is used in the new generation domestic refrigerator. Its chemical formula is A CHClF2, B C2Cl3F3, C C2Cl2F4, and D C2H2F4. So in theory already we discussed about methane based and ethane based hydrocarbon. So in that problem it's a ethane based hydrocarbon. So now let's solve this problem. So according to the theory, the ethane based hydrocarbons are having three numbers and the first number is always 1, and now we can find out the number of hydrogen atom. So the number of hydrogen atom will be second digit minus 1. So here I am having R134A. So first number is 1 for every ethane based refrigerant, and the number of hydrogen atom is nothing but second digit minus 1. Second digit is 3 So the number of hydrogen atom will be 3 minus 1 equals to 2. So now we will see number of fluorine atoms. So number of fluorine atoms will be third digit. Third digit. So it is 4. So now it is 4. So now number of fluorine atom. So the number of fluorine atom. So if you see here in ethane based refrigerant there is a 6 hydrogen atoms, and in that problem already there are 2 hydrogen atom and remaining 4 hydrogen atom is replaced by fluorine atom, so the number of fluorine atoms will be 0. So now I will write the chemical formula. So it's a ethane based, so obviously C2. Hydrogen atoms are 2 and remaining 4 atoms are fluorine atom. So the correct answer is C2H2F4. So the correct answer is D, C2H2F4. Now let's take another problem which is asked in GATE 2004. So I am writing problem for GATE AME 2004. A heat engine having an efficiency of 70% is used to drive a refrigerator used to drive a refrigerator having a having a coefficient of performance coefficient of performance of 5. The energy absorbed by from low temperature reservoir by the by the refrigerator refrigerator the energy absorbed by from low temperature reservoir by the refrigerator for each kg of energy absorbed from from high temperature source by the engine. High temperature source by the engine is 8.14 kilojoule, B 0.71 kilojoule, C 3.5 kilojoule, and D, that is 7.1 kilojoule. Now let's solve this problem. Here there is a heat engine and the work output from this heat engine is used to drive the refrigerator. So now here first I am drawing the heat engine. Source is at T1. Heat taken by source is Q1. This one is heat engine producing work W. rejecting heat Q2 to the sink, which is at temperature T2. Now this work is useful in running refrigerator, and in refrigerator again we are having high temperature, that is T1 dash. So supplying to T1 dash, this Q1 dash. Here we are having T2 dash, lower temperature, heat taken, that is Q2 dash. So this one is a arrangement of heat engine and the refrigerator. So now in the problem, efficiency of engine is given equals to 70%, or I can say 0.7. Similarly, COP of refrigerator is given, that is 5. So now from the diagram I can write efficiency of engine equals to W by Q1. So zero point 0.7 Q1 equals to W. I am getting from here. Similarly, for COP, I can write Q2 dash divided by W equals to 5. So Q2 dash divided by, I can write 0.7 Q1 equals to 5. So Q2 dash by Q1 equals to 5 into 0.7, so 3.50 Q. I am again writing Q2 dash by Q1. Q2 dash is nothing but energy absorbed from low temperature reservoir by the refrigerant, and Q1 is nothing but energy absorbed from high temperature source by the engine. So this ratio is coming 3.5 kilojoule. So correct answer is C, 3.5 kilojoule. Now let's take another important problem which is asked in year 2004. So GATE AME 2004. I'm just writing the problem here. R12 refrigerant refrigerant reciprocating compressor operates between the condensing temperature of the condensing temperature of 30 degrees centigrade and evaporator temperature of and evaporator temperature of minus 20 degrees centigrade. The clearance volume ratio the clearance volume ratio of the compressor is 0.03. Specific heat ratio is 1.15, and the specific volume the specific volume at the suction is 0.1089 meter cube per kg. Other properties at various states other properties at various states states are given in figure are given in figure to to realize 2 tons of refrigeration, find the actual volume displacement rate. Find the actual volume displacement rate displacement rate considering the effect of clearance. Considering the effect of clearance. So let's solve this problem. First of all, I will draw the diagram here, that is pH diagram. So I will draw first the pH diagram. So this one is P and this one is H here, and diagram is looking like. So now we are having from 1 to 2 is a asymptotic compression, and this 2 to 3 it is a constant pressure heat rejection. 3 to 4 that is isoenthalpic process, that is throttling process. 4 to 1 that is constant pressure heat addition. So this pressure I will saying in terms of bar here, and these values are in kilojoule per kg. So here I will say this one is 65, this one is 176, this one is 207. Here in terms of pressure, here 745, here 150, and the temperature 30 degrees centigrade and minus 20 degrees centigrade. So this one is a typical representation of vapor compression cycle on pH diagram. So now let's solve this problem. So in that problem, clearance volume ratio, that is C, is given 0.03. The specific volume at suction, that is V1, is given 0.1089 meter cube by kg, and refrigerating effect is 2 ton. So in terms of kilojoule, it will be 2 into 3.516 kilojoule. So it will be 7.032 kilojoule per second. Specific heat ratio, specific heat ratio, specific heat ratio for us it's N equals to 1.15 is given. Now refrigerating effect is nothing but M into, here we are having the refrigerating effect, so H1 minus H4. So refrigerating effect we are having 7.032 equals to M. Here H1, if you see here, it is 176 and H4 it is 65. So I can write 176 minus 65. So by this way I will get the value of M, that is 0.063 kilogram per second. So now volume will be volume will be 0.063 into 0.1089. So that is volumetric rate. We can say that volumetric rate. So 0.063 into 0.1089, 6.89 into 10 to the power minus 3. So this one is the volumetric rate. Now we can find out volumetric efficiency. So volumetric efficiency is NV equals to 1 plus C minus C P2 by P1 to the power 1 by N. So NV 1 plus C is 0.03 minus 0.03. P2 is 745. Here it is mentioned. It is 745. P1 is 150. So that is 150. 745, 150 divided by to the power 1.15. So the volumetric efficiency will come 0.909. So the volumetric efficiency will come 0.909. So now the actual volume displacement rate, actual volume displacement rate will be volumetric efficiency is NV into volume flow rate. Volume flow rate. So 0.909 into 6.89 into 10 to the power minus 3. And if we calculate this thing, we will get 6.26 into 10 to the power minus 3 meter cube per second. So the correct answer is 6.26 into 10 to the power minus 3 meter cube per second. So now let's take another problem which is asked in year 2003. So get AME 2003 problem. An industrial heat pump and industrial heat pump operates between the temperature of 27 degrees centigrade and minus 13 degrees centigrade. The rates of heat addition, the rate of heat addition and heat rejection are 750 watt and 1000 watt respectively. Find the COP for heat pump. COP for heat pump. Heat pump. Let's solve this problem. I am giving solution for this problem. I am just drawing the heat pump. Here is G1 Kelvin. This one is heat pump. This one is sink G2 Kelvin. This one is the heat addition to the heat pump. And this one is the heat rejection, that is Q1. And rates are given, so I am putting Q1 dash, Q2 dash. So Q1 dash, that is here heat rejection will be 1000 watt and heat addition is 750 watt. So remember one thing, it is not mentioned like it's a reversible heat pump. So we have to always take the general heat pump and the general formula for COP of heat pump. So the COP of heat pump will be Q1 divided by Q1 minus Q2 in terms of heat rejection or addition rate. Q1 dot divided by Q1 dot minus Q2 dot. So Q1 dot is 1000, Q1 dot is 1000 minus Q2 dot is 750. So COP of heat pump will be 1000 divided by 250, so it will be 4. So the correct answer for this problem, the COP of heat pump is 4. Now let's take another important problem which is asked in year 2003. So I am writing the problem here. Get AME 2003. A refrigerator based on ideal vapor compression cycle operates between the temperature limits of minus 20 degree centigrade and 40 degree centigrade. The refrigerant enters the condenser as saturated vapor and leaves as saturated liquid. The enthalpy and entropy value the enthalpy and entropy values for saturated liquid and vapor at this temperature at these temperatures are given in table below. So now I am drawing the table here. So this one is a typical table which shows the value of saturated vapor and liquid. T degree centigrade, we are having HF in kilojoule per kg. We are having Hg in kilojoule per kg. We are having SF kilojoule per kg Kelvin, that is entropy. Sg kilojoule per kg Kelvin. So now we are having two temperatures here. Is at minus 20, 40. Minus 20 values are 20, 180.07, 0.7366. So 40 values are 80, 200, 0.3, 0.67. So find refrigeration effect if refrigerant circulation rate is 0.025 kilogram per second, and also find COP. So now let's solve this problem. So I am giving the solution of this problem. So here I will draw the pH diagram for our understanding. pH diagram. So I am drawing the pH diagram. Here in the problem it is mentioned the refrigerant enters the condenser at saturated with. Suppose this one is entry point at condenser. Saturated with, leaving saturated liquid. It's a constant pressure process, so this one will be. So before entering into the condenser, there will be compression which is isentropic. So compression will be like that. So we are starting from here for compression. Compression will end here. It will enter into the condenser and leaving at point 3 to 4. It's a throttling process. So now if you see the state 2 is saturated vapor, state 3 is saturated liquid. But if we see 1 to 2 process, it's a isentropic process. So 1 to 2 is isentropic process. So for this process, what we can write for this process? S will be C. So I can write S2 equals to S1. So S2 is nothing but entropy for saturated vapor at 40 degrees centigrade. So this temperature is 40 degrees centigrade. This temperature is minus 20 degrees. So we have to find out entropy at point 2 is nothing but entropy for saturated vapor at 40. So at 40 degrees centigrade, saturated vapor entropy will be 0.67. So I will write 0.67 equals to. For 1, if you see the 1.1 is a state, it's a mixture state. It is a combination of vapor and liquid. So for that I can write SF plus X Sg minus Sn. So now we have to put all these values for 40 degrees centigrade, for minus 20 degrees centigrade, because 1 belongs to minus 20 degrees centigrade. So 0.67 SF will be for minus 20 degrees centigrade, SF will be 0.07, Sg will be 0.7366. So if we put this value, I will get 0.07 plus X Sg is 0.7366 minus 0.07. So I will get 0.67 equals to 0.07 plus X into 0.6666x. So if you solve it, you will get the X value is 0.9. So now we got the value of X, that is 0.9. So we can say that X equals to 0.9 at state 1. So now let's find out enthalpy at 1. Again the same formula, HF plus X Hg minus HF, that is at minus 20 degrees centigrade. So H1, if you see HF at minus 20 degrees centigrade is 20 plus X we know 0.9, Hg at minus 20 is 180 minus 20. So H1 equals to 20 plus 0.9 into 160. So H1 will come 164 kilojoule per kg. That is H1. H2, the 2 value, that is the state 2 is nothing but saturated vapor state at 40 degree centigrade, means the value Hg we have to take for 40 degree centigrade. So H2 will be 200 kilojoule per kg by table. Similarly, H3 is nothing but saturated enthalpy of saturated liquid at 40 degree centigrade. So from table it is 80 kilojoule per kg, and 3 to 4 is constant enthalpy. So H4 equals to H3 equals to 80 kilojoule per kg. So now we are having enthalpy at each and every step. So now let's find out refrigerating effect. So the refrigerating effect will be m dot into the refrigerating effect will be H1 minus H2. And in the problem, m dot, that is refrigeration circulate rate, is given 0.025. So now refrigerating effect 0.025, H1 is 164, H4 is 80. So refrigerating effect will be 0.025 into 84 will come 2.1 kilojoule per second. So 2.1 kilowatt. So the correct answer for refrigerating effect will be 2.1 kilowatt. Now we have to find out COP. So COP for this refrigerator is nothing but refrigerating effect divided by W. So refrigerating effect we are having 2.1 and W, that is compressor work. So M H2 minus H1. So COP of refrigerator equals to 2.1 M 0.025 into H2, that is 200 minus H1 164. So COP of refrigerator will come 2.1 by zero point 0.9, so it will come 2.33. So the COP in that case will be 2.33.